All right, so the last part of the lesson involves graphing. So for these problems, we're going to start by identifying the function. We're going to state any transformations. We need to state domain and range and graph. So we're going to do the graph part before domain and range for these. All right, so for 10, since there's no squared, no absolute value, this will be a linear function. The transformations, we have a compression by 1/3. So that means when I graph this, I'm going to expect it to be flatter than it normally would be. And then we went up 2. All right, so since it's linear, we start at the y-intercept. So we're going to go up 2, put our point. And then our slope is 3, so we go up 1 over 3, put our next point. And then we're connecting them into a straight line. So if I'm looking at this, the domain is going to be all reals, and the range is all reals. All right, the next one, so we have the absolute value symbols in there, so that means that this is an absolute value. So when we graph it, it's going to make a V shape. So our transformation, so we have a stretch of 2. So that means when we graph it, our V shape, since it's going to get steeper, so if this is our V, when we graph it, it's going to get steeper together. Versus the compression, that's going to make your V go flatter. All right, so this one we also went to the right 3, and then we went up 1. Okay. So to graph, we want to do a T-chart for this one. And we always want to start with our vertex point. And we're going to put that right in the middle of our T-chart. So the vertex is going to be 3, 1. So again, the opposite of our H. So this is H, K, 1 in front is A. And then to get the rest of our V shape, we need a point on each side of our X value for the vertex so that we can get a point on each branch. So I'm just going to add 1 to 3. So that would give us 4. And then I'm going to subtract 1. So that's 2. And then now we are substituting it. So I'm going to kind of do that off to the side here so you can see where I'm getting the y value. So we would have 2, and then I'm going to replace x with 2. So 2 minus 3 plus 1. So now we're just evaluating. So we're simplifying. So 2 minus 3 is negative 1. And then we have to take the absolute value first. So that gives us a positive 1. So I'm going to switch to parentheses. And then now we're multiplying, so 2 times 1 is 2, plus 1 is 3. So that's my y value. And then I'm going to do that same process with the 4. So 2 absolute value of 4 minus 3 plus 1. So again, 4 minus 3 will be 1. Absolute value of 1 is 1, so now we switch to parentheses. 2 times 1 is 2, plus 1 gives us 3. Which is exactly what we want to happen. So these y values should be the same because our graph is symmetrical. So to graph, we're going to go right 2 up 3, right 3 up 1, right 4 up 3. And then again, this is an absolute value, so we're going to connect our 3 dots into that V shape. All right, so looking at this, the domain for this function is going to be all real numbers because it's going left forever, right forever. And then our range, we need everything above 1. So it's going to be in between 1 and positive infinity. So infinity, we have a parenthesis. We include 1, so we have a bracket. So that would be the range for that function. All right, our next example. So looking at this, that squared tells us that we are dealing with a quadratic, which means when we graph, it's going to be a U shape. So transformations, again, we have a compression. So compress 1/3, so that's going to make our graph wider. And then we went down 2. So again, to graph, we're going to make a T-chart. We want our vertex to be in the very center of our T-chart. So since we don't have a grouping symbol, that means that our H is 0 because it's not there. And then our 1/3 is A, the negative 2 is K, so that's going to be the Y value of our vertex. Now again, normally when we pick x's, we're just going to add 1, subtract 1. But this time, if I do that, 1 squared is 1, and then times 1/3 is going to give us a decimal to graph. And it's not even a nice decimal. So I'm going to choose my x value a little bit more strategically this time. So I need a number that when I square it, it's divisible by 3. So I'm going to choose 3 for my x. So by choosing 3, so if we go over here to do our side work, we would have 1/3 times 3 squared minus 2. So 3 squared would be 9. And then we're taking that times 1/3. So 1/3 is 9. So we're dividing by 3 is going to give us 3. So now we have a nice whole number to work with when we're graphing. So since I added 3, on the other side, that means I'm going to subtract 3. So I would choose -3 here. Okay. So again, substituting in, we would take 1/3, and then this time it's -3 squared minus 2. So -3 squared is still going to be a positive 9, times 1/3 is 3, 3 minus 2 is 1. So that's our y value. Okay. So we're going to go left 3 up 1, down 2, and then right 3 up 1. And then again, it's a quadratic, so when I connect these points, I have to connect them into a U shape. So it has to be rounded kind of at the bottom. Now, I don't expect a perfect U, but it cannot look like a V. All right, last part of this problem is domain. So again, it's going to go to the left and right forever. So our domain is going to be all reals. And then our range, we need everything above -2. So it's going to be in between -2 and positive infinity since it's opening up. And parenthesis around the infinity, bracket around -2. All right, our next one that we are dealing with is a constant. So we don't have to worry about any transformations for this one, so we're just going to graph it. So we're going to go down to -3 on the y, and then we're going to make a horizontal line. So the domain for this one is all real numbers, because it's going left and right forever. And our range, the only y value that we ever are going to have, is -3. So we need curly brackets around that one. Okay. Now I don't have it written on here already, but I am going to add in one more problem. So we're going to make a 14 here. So let's say we have y equals -3 times the absolute value of x plus 1 plus 4. Okay. So looking at this, it's going to be an absolute value. So when we graph it, it's going to be a V shape. Our transformations. So the negative tells us that we have a reflection. The 3, so I'm going to ignore this part. The 3 tells us that we have a stretch. Okay. So it is okay to have a reflection and a stretch, or a reflection and a compression. So sometimes that does happen. So the negative is the reflection. The number bigger than 1 is going to be either your stretch or reflection, which is why I wanted to add in this problem to make sure that we understood that. Okay. And then we went to the left 1 and up 4. Okay. So to graph this one, again, we want to start with our vertex. So the vertex is -1, positive 4. And then this time we can just add and subtract 1 from our x value. So if I add 1, that will bring us to 0. If I subtract, it'll give us -2. And then now we're going to substitute. So again, I'm going to do a little bit of side work over here. So -3 times the absolute value. I'm going to start with 0. So 0 plus 1 plus 4. So 0 plus 1 is 1. Absolute value of 1 is 1. And if we take that times -3, that will be -3, and then plus 4 gives us positive 1. And because we know that this is symmetrical, my y value for that one is also going to be 1. So the next thing that we want to do is the graph. So let me make my x and y axis. So we are going to go left 2 up 1, left 1 up 4, and then up 1. And again, this is absolute value, so that means that we're connecting it into a V shape. Okay, so this graph should have done exactly what we expected. It flipped over because it's a reflection. Our lines got a little bit steeper, so a little bit closer together. The vertex point moved up from our origin and to the left. Okay. So we know that we graphed it right. So again, the transformations are to give us an idea of what our graph's going to look like without actually having to graph it, or if we do graph it as a way to double check to make sure that we graphed it correctly. Okay. All right, last part of the question is dealing with domain and range. So again, domain is all reals because it's going to expand right and left forever. And then our range this time, it's going to be everything below our y value at this point. So that's 1, 2, 3, 4. So it's going to be from negative infinity all the way up to positive 4. Parenthesis around negative infinity, bracket around 4. And that is going to conclude section 7.